Welcome to Nomenclature 1. Here's what I expect you to know before we begin. You need to know the names of the first 20 saturated acyclic hydrocarbons from methane to icosane. You need to know the names of the first 20 alkyl groups from methyl to icossyl. You need to know the names of the halogen groups fluoro, chloro, bromo, and iodo. For example, here's the molecule heptane. 1, 2, 3, 4, 5, 6, 7 carbons long. Here's a group on heptane. It's clearly on the third position of heptane, and it is a 2-carbon group, making it an ethyl group. Let's get started. Our first objective is to name this molecule here, and here is where the parentheses might cause you trouble. So my suggestion is that you get rid of the parentheses and replace them with the groups. What does this 2 mean here? When it's outside the parentheses, it means that there are 2 of these methyls attached to the carbon following. This is the only time that parentheses will mean attached to the next atom in, when the parentheses are on the far left of the molecule. We see another example that is more normal, where the parentheses are in the middle of the molecule. This always means that that group that is highlighted is attached to the previous carbon of the chain. That is a propyl group attached to the previous carbon of the chain. So let's put a line through it. Put a propyl group off of here. And put a line through the methyl group. Keep in mind, there are really 2 methyls, so let's put them both on here. And you might think that's 2 methyls, like we said, but that would be an error. One of them is really the end of the chain. Notice my computer program likes changing things on me. After I cross this off and put the group on it, change the number of H's, so it's wrong now. But let's just move on. Numbering the chain. Always choose to number the chain so that the first group is on the lowest possible number. If I had started from this end, that would be in error. I will prove why. You do not hit a group, or still not hit a group, until carbon number 6. That numbering is incorrect. I will get rid of it. The original numbering put it, the first group on 2. The second set of numberings put it on the first group on 6. That has to go. So we're at carbon 1, 2, 3, 4, 5, 6. We have a group on 6. Then the next carbon in the chain is here, 7, 8, 9, 10, 11. A molecule with 11 carbons. I'll just copy this. 11 carbon chain ends with the name undecane, which means 1 plus 10. Now, we have to put the group names in front of that. So, what are our groups? Up here we have a group. I'll put a circle around it. Oh, bad choice. Put circle around it. Ask yourself how many carbons are in that group. The answer is 1. That makes it a methyl group. Groups end with YL. I'll put a circle around this, circle of sorts. We will call that propyl because it has 3 carbons. We have to put the groups with the chain name here. The methyl group will go first because it begins with an M, not because it's on carbon 2, only because it begins with an M. M is before P. So my molecule is methyl propyl undecane. This is not the end. The methyl group could be anywhere along the chain. You must indicate exactly where the methyl group is in the chain. It is attached to the second carbon of the chain. You put a 2-methyl. Numbers are always followed by dashes. The propyl group is on carbon 6. If there's a number in the middle of the name, then a dash precedes it, and there is a dash after it. Congratulations, you have given your first name, 2-methyl 6-propyl undecane. To name this molecule here, we must decide which direction to number the chain. As we did before, we consider the 2 options. Keeping in mind, if I'd started with carbon number 1 here, I would not have the longest chain of this molecule that is possible. So I have to start here and end here as one option, or start here and end here as another option. Let's just go up until the first group and see if we can make a decision. We cannot make a decision. Numbering in the blue system, first group is on 2, and in the red system, first group is on 2. When we have such a tie, we have to go and find the next group. Here's 3, here's 4, here's 5, here's 6 with the red system. Second group on 6 with the red system. With the blue system, 3, 4, 5. We have a winner. Because the second group is on 5, which is lower than 6, which means blue wins. I'm going to erase red so it doesn't confuse me later. Carrying on. This is 6, this is 7, this is 8. We have a group on 8. This is 9, 10, 11. And 12, 13, 14, 15. And that makes our chain length 60. This molecule will end with the name hexadecane, indicating 6 plus 10 carbons, that's 16. Groups. I will go alphabetically. Bromo before ethyl, that's B before E, There are two ethyls. We'll deal with that in a second. Then fluoro is listed next, and methyl last. Once again, on carbon 15, there is a bromo. Ethyls are next. There are two of them. I need two numbers. 5 is the first ethyl. 11 is the second ethyl. To indicate there are two ethyls, you use the prefix di before ethyl. Then on carbon 8, there is a fluoro. Then on carbon 2, there is a methyl. And you have your name. And we'll move it so we can read it more clearly. And there it is. Big box. There you have it. Next up, we're going to draw a 3-fluoro Nany. Start by drawing a 9-carbon chain. Nany being 9. You decide which direction you want to go. Put a carbon 1 there. Put a carbon 3 there. Off of 3, draw a fluorine group. And you will be home free. Congratulations. Next up, we're going to draw 6-butyl, 3,3-diethyl, 2,8-diiodo, 8-propyl heptadecane. Seems intimidating. Don't let it be. Break it down. Always start at the end. Heptadecane. 17 carbons coming right up. Yeah, I got 15 there and I ran out of space. Not a problem. 2 more. 1, 2. Just for variety, I'll go right to left on this one. Got carbon 1 over there. I need a 2. I need 3s. 2 groups on 3. I need an 8. 4, 5, 6, 7, 8. Looks like I have 2 groups on 8 as well. Off of carbon 2, I draw an iodo group. That is an I. Off of carbon 3, I have 2 ethyl groups. Please draw them separately. Do not think that a diethyl is the same as a butyl. There is one of the ethyls. Here is the other ethyl. Off of carbon 8, I have another iodo. Also off of carbon 8, I have a propyl. That is a 3-carbon group. I think we saw one earlier. I forgot carbon 6, didn't I? Carbon 6 has a butyl. That is a 4-carbon group. Oops. Doesn't have to look pretty. Let's verify. 6-butyl, 3,3-diethyl, 2 ethyls on 3, 2,8-diiodo. Carbon 2 has an iodo. Carbon 8 has an iodo. 8 has a propyl. Heptadecane. Verifying heptadecane before I quit. 8, 10, 12, 14, 16, 17. And we are done. Congratulations.